This one's easier, so I thought I'd start with the easier of the two, and we'll go from there. All right. I wish I had numbered these pages. I apologize. It would have been easier. But I'll look for this guy. All right. So, I'm going to take this gum out because you can hear it in videos. It's gross. You ever hear me chomping on gum in them? They're gross. What was I going to say? So the flow of this chapter will be we're going to get all the way through our series tests, and then you're going to stop and take a test on the series tests. That'll be not next week, but probably the week after. Then we pause, and we do what's called parametric polar review for 3 days to bring it back, and then we finish the rest of the series stuff, which isn't the tests on convergence or divergence. It's some specific famous series. It's Maclaurin, it's called, and Taylor, and Power series is what we talk about at the end. So the chapter is going to get kind of split. All right, so you will have a test on all these tests eventually. We're on test number 3 for College Board, 4 for me, because they don't do telescoping series. All right, so a p-series is set up in a specific form. It's 1 over your count to a power. So here's some examples. If you can recognize a p-series, you can determine its convergence or divergence in your head. So it might be 1 over n squared. I'm just going to put comma so I don't have to keep writing the series thing. It might be the sum of 1 over n. It might be 1 over the cubed root of n. It might be 1 over n to the 5th. All of these guys are called p-series. 1 over n to the p. The value of the p determines the convergence or divergence. So the most important one is this guy. He gets a specific name, and we're going to be using it a lot later. It's called the harmonic series. And this one right here, we did in an exploratory way. Do you remember what we said that one did? We did it on the calculator. It did what? Diverged, and we call it the fence for divergence. Does this sound familiar? Do you remember when we were integrating those, and we were integrating the improper integral? Was very similar. The difference between this is it goes 1, 2, 3, 4, 5. The difference in this one, it's running through all real numbers on the way, but they're super similar, correct? Do you remember when we did the x to the p? What values of p made the integral converge? Go to 0 fast enough. When p is, see if you remember, other way around. Greater than 1, the denominator would get big and it sends us to 0, drops us below the fence. The 1 over x is the fence. So this guy, 1 over x is the fence. Anything over will diverge. Anything under will converge. It itself diverges. Does that make sense? So 1 over x to the 5th converges. And for the integral, we could find what it converged to as well. But so this runs really similarly. It says this, if p equals 1, so it's just that harmonic, this is the divergent harmonic. So, and we'll be using that quite a bit. We'll prove its divergence 2 ways. I don't know that we'll do that today. It might be something I skip for today. If p is less than 1, you should try to not memorize these. If p is less than 1, like 1 over p to the 1/2, right? Do you think it will diverge, or do you think it will converge? Diverge, Afnan. Yeah, it'll ride up above the divergent. If you're over a divergent, you diverge. If you're under a convergent, you converge. So anyway, this would also diverge. That would be like 1 over the cubed root, or 1 over, sorry, that should be a n. Next one, if p is greater than 1, so you have like 1 over n squared, 1 over m to the 5th. The higher the power, the faster it falls, right? So like 2 to the 5th, it'd be 1/32nd. 2 to the 6th, that'd be 1/64th. It drops it really fast, makes it converge. So if p is greater than 1, we will converge. So the p-series, we're almost done with it. If it looks like a p-series, you just look at the p, and then you can answer the question. All right? I think some of you who are in taking that BC exam, I think there's one question in there that says, which of these converge? And I can't remember, but I think one of them might be a p-series, and now you'll know that one. All right, so let's go take a look. This right here, if I write it, it looks sort of p-series-ish. So I'm going to write it with its p or its power. It'd be p to the 3/2, correct? So I can now conclude, it's a super easy test. I can now conclude that that is what? convergent. You can't just write converges because that's a 50-50 guess. You have to write convergent. You're going to tell me it's a p-series, and you have to tell me why it converges with p equaling 3/2. But it's not because it equals 3/2, it's because it's greater than 1. Those details are important. The next one is not a p-series. Write it with a power. What is it? Okay, so let's talk about this. This would be n equals 1 to infinity, n to the 1/2, or root n. That's not a p-series. P-series have to be 1 over n to the p, but you should be able to tell me what that does. Anyone want to tell me? It's confusing. It grows slowly, but remember, it's all about its limit. What's the limit as n goes to infinity of the square root of n? It will diverge, right? So you're going to say the limit as n approaches infinity. By the way, you should always run which test first in your brain. Nth term. This one was inconclusive because my limit's 0. This one, I'm running the nth term now that it's not looking like a p-series. And the limit, I'm just going to call that a sub n, is actually equal to infinity. So it's not because it equals infinity, though. Are you starting to get the details down? Because they have to be. That's what's hard about this chapter. There's so much you're going to have to kind of file in a specific order. So it's because it what? Doesn't equal 0. So you'll say, therefore, let's call it S. S does what? Diverges. And then, Larkin, you also, once we get up to 9 tests, you have to tell me which test you ran by the nth term. Exactly. So I'm actually pretty impressed. Usually this is really rocky until you take the first quiz and get it back with all my writing on it, and you'll be like, oh, that's what I'm forgetting. But this is good, actually. By nth term test for divergence. There we go. The next one, it might be a p-series if you can write it as 1 over n to the p. Can you? Yes, so we will. P-series are nice. This would be 1 over n to what power? 1/2. That's really what this guy is. We're almost done with p-series, because if it can be written as a p-series, you just analyze the p. In this case, p is less than 1. So what will we do? Diverge. Yep. Again, 1 is the fence for divergence. Any number less than that causes us to diverge. Greater, converge. So we'll say p equals 1/2 less than 1. Therefore, yep.
Why wouldn't it be less than or equal to 1?
It is. I just thought of that as you're saying it. I was like, I better put it equal, and I said yes. So therefore, right, S does what? You guys can wrap it up. Therefore, S diverges by p-series test. Yep. So, or you could say it is a divergent p-series. Your wording doesn't have to be super great. I'll bring up an FRQ so you can see how they're graded once we do the integral test, because that's the one that most of this is honestly usually multiple choice. So you can be not quite as awesome. But what do you think I'm going to tell you to do with this guy? What can constants always do for any limit, integral, or derivative? I would pretend it's out front. Constants don't really affect our end game. They just determine what things converge to, but not the act of convergence. So on this one, that is some constant times a p-series. If this is multiple choice, up until now you would have looked at that and gone, what the heck is that? Now you should go, oh, p-series with p greater than 1. So it what? Converges. So do you see what I mean? If you can keep the test straight in your head, series are not too bad. It's people who struggle with memory that actually struggle in p-series. It's not the math. What else was I going to say? Do you notice for the ones that converge, I can't tell you to what they converge. What are the only tests that I can tell you to what it converges? Geometric, AP. Geometric or telescoping for Larude, but I'll tell you if it's telescoping so you know. So basically, if you're not told and it says to what does this converge, it is a what? Geometric beyond a shadow of a doubt. So those 9 of you taking that BC test, if there's one in there that says, to what does this converge, you're going to go, this has to be geometric. It's the only one. There's other ones we can get like an approximate, but geometric's the only one that has a formula. So speaking of that, now we're moving on to integral tests. So we're going to go back. This is the worst one. So I have to go slower and I have to, like, go ahead, here, watch if I read this to you. I will. I normally don't read to you. But if f is decreasing, continuous, and positive for x greater than or equal to 1 and a sub n equals f sub n, then the summation from 1 to infinity of a sub n and 1 to infinity of f of x dx either both diverge or converge, and then the series converges to s, then the remainder r sub n, which is the absolute value of the difference between s of s sub n, is bounded by 0 less than or equal to r sub n less than or equal to the integral from n to infinity of f of x dx. So this means s is an element of s sub n, comma, s sub n plus r sub n. Do you get it? Maybe parts of it. Is there any part you got with me reading it that fast? It's called the integral test. Awesome. That is the hypothesis, and that needs to be stated if you're going to use this test. That's one of those like IVT, MVT things. Dogs, curse, and prison helps with that. Dogs decreasing, curse continuous, and prison means positive. You have to verify those 3 things to use the test. And if you don't write it down, watch. I snuck one in from a past, this was actually the 2017 test. They had to, right here, evaluate the integral. I'm just going to go show you. Do you see right here where it says answer with conditions? 2 points. So by condition, it means these. So what do you think you get if you put the answer without the conditions? 0. So that's super, those little things in the hypothesis is super important. You get 0 out of 2 just because you didn't put down that you knew you could apply it. But it makes sense because if I say, if you are wearing a gray sweatshirt, you can be done for the day. Let's make it the year, and I'll give you an A+. Is that gray or white? 1, 2, 3. Those of you who aren't wearing gray are immediately like, I'm not even listening to you anymore because you said if, right? So you have to meet the if to apply the theorem. So if you don't meet the if, they don't care that you applied it correctly. Does that make sense? So we have to be very careful. Now, so again, Sydney, you did say it's called the integral test, yes. And then Luke said, well, it has to be decreasing, continuous, and positive. This part's pretty easy to understand as well. What it's really saying, if I take it out of its gobbledygook, is that if I replace the rule of sequence as a function of x, so if I had this, n equals 1 to infinity of 1 over n squared plus 1, and I write it as an improper integral, right? That's what that's saying. They're just saying consider the integral, right? It's basically saying they have the same behavior. Do you see that? They either both converge or they both what? Diverge. So if I can show this improper integral goes to infinity, it means my series also diverges. Does that make sense? If I evaluate my improper interval, by the way, maybe you could do that in your head. This is arctan, right? Wouldn't you agree? If I could evaluate that and get an answer, then this converges to that answer. This also converges, but not to that, because they go at different paces. Does that make sense? And again, this is kind of considering all real numbers on the way. This is the counting numbers, but they have the same behavior. Are you okay with that test? You're nodding. I like it when you nod. It means you're paying attention. It means you get it. All right. So I usually look at Rand when I go, does that make sense? Because he's the one that sometimes is out to lunch a little bit. Sometimes your eyes go out like you're thinking something else. I can see it. Do you find in your brain like going away for a little bit? That's why I always look at you. I'm like, come on. It's like, whoa, come on. All right, you ready? I forgot I'm wearing this. That's the worst. I'm going to keep going. All right, here we go. So that's what this says. First of all, function must be decreasing, continuous, and positive. You really don't need to verify it on paper, just in your brain. You notice on the AP test, it didn't say why they were, it just said that they were. All right, also, this is going to be on hold for a second because I'll explain it. You can't tell me what it converges to, but you can give me a safe window. So by the end, you'll be able to say, I don't know what it converges to, but I know it's between these two numbers. You'll be able to get me what I call a confidence interval if you're in statistics. Have you started talking about those yet? So, but we're going to be 100% confident that our actual sum is within a certain numerical region. We'll talk about that after we go do a couple. Again, I'd highlight and star that. What am I telling you, just in case you've been absent? Test one, similar. All right, so here we go. It says determine whether these series converge or diverge, and we're going to use the integral test. You will, if given the choice, avoid it as much as possible. You'll try any of the other 8 tests. But there will be some where you'll be like, oh crap, I gotta do the integral test. Does that make sense? So I'm going to tell you what the trigger is for it. This is when I go, oh, none of the other ones are going to do it for me. Usually, my trigger for the integral test is the natural log function. Usually. Do you see it in either of these two? It means as I finish and we're done with all 9 tests, you would choose a different one for these. I've chosen them to show you procedure, but I wouldn't. A week from now, I'd actually do letter B with what's called a direct comparison test. And I would do letter A with what's called a limit comparison test. I can do it in my head. All right. Because both of these go to 0 and it's inconclusive. So that's a really good thing. Let's run it through our head. The limit as n approaches infinity of my rule-less sequence, what does this go to? 0. Right now it's infinity over infinity, but L'Hopital gives me 1 over 2n. That's going to 0. Nth term test is a one-way test for what? Divergence only, right? And it's if I get anything other than 0, I can stop and say this diverges. You can never say we converge by the nth term test for divergent. It's a one-way test. All right, right here, what's this guy's limit as n goes to infinity? Good to think about it first because I would have forgotten. We actually should always run that one through because it's so slick, right? But what's the limit? 0. The minute I go like this, though, what's the limit as n goes to infinity? 4, not equal to 0, therefore diverges by the nth term test. So really, you guys are really, this is good. Usually this does not go quite this well, although I haven't graded anything yet. I get a good vibe. How are you doing, Sophie? You're very quiet. She's good. Were you gone yesterday? All right, so here we go with the integral test. What it says is, bail on the series, use your integral notation for summation, which adds up an infinite number, right? We're going to go from 1 to infinity. Bail on n being the integers, and let's have it be x for all x. This and this will have the same behavior. So I'm going to go back to chapter 3 or whatever, when we evaluated improper integrals. You will need to show the notation correctly if it's on an FRQ. So, and that's a weakness of ours. You guys like to just treat infinity as a number. Great for multiple choice, but Eli, you're really good at that notation. Can you tell me how I'd write this? Or B. I like B. I'm partial to B. But I don't know. That's how I was taught it. Yep, I do. And that limit stays out front until I've antiderivated and plugged the b in. A lot of you drop it like right away. And on the AP test, I'll show you it. I have it right in here. I just want you to not think I don't think you think I make stuff up. But on the AP test, you'll notice it says limit expression. So if you don't pass off to the limit in an FRQ, you're going to forfeit another point. So if you're sloppy on this question, you lost 3 points. So it's very important. All right, so let's go back. So Eli, here we go. We are going right to this one. We're trying to figure out if the integral converges. What process would I use to integrate this? U sub, you could probably do it in your head, couldn't you? It's u sub with u being x squared plus 1. du is 2x dx. So what am I going to need? I'm going to need a 1/2, but then it'll be 1/2 1 over u du. So it'll be natural log. Absolute value not necessary because I'm squaring positives and adding 1. correct? It's going to go from 1 to b. I still don't drop my limit. You don't drop it until it's been plugged in, and then you send it to infinity. Chuckles, how are you doing? All right, so now what do? I'm going to, oh yeah, I could move the constant out front, right? And I could say I have the limit as b approaches infinity of the natural log of b. Do you see why we're going to avoid this test at all costs? Well, the p series slick. Geometric series, great if it's geometric. Nth term test for divergence in my head. This one is labor intensive and it's got something I neglected to do, which I have to go back. All right, what else goes in here? I'm not done yet. Minus ln 2. So now we have to, now you consider putting b going to infinity. What's this going to go to? Infinity. This is a constant. Agreed? So what do you think infinity minus the natural log of 2, which is very small, is? Infinity. Infinity plus or minus anything is what? Infinity. So what's my answer to this? Diverges. Okay? So this is infinity. So you're going to say this. Therefore, the integral and the series, what do they both do? Diverge. They both go to infinity at different speeds probably, but they're both going to go there. By the what test? Now, I would lose a point for this on an FRQ. Does anyone want to tell me why? I didn't state that the conditions were met, and I would lose that. So anytime you launch into the integral test, you're going to have to say that f of x, which equals x over x squared plus 1, it has to be 3 things, and you have to memorize them. Dog's curse and prism. What must it do as x gets big? Are you convinced that would? Yes. You could take a derivative and it'll be negative, but you don't need to. You just need to convince yourself that that decreases. It also has to be continuous. So no holes, no asymptotes, no jumps, no gaps. Are you convinced that that's safe for all real numbers? Yes. So it's just a convincing in your head. You don't have to write anything down. I won't make you. And it also has to be positive. Are you convinced that that's positive for all x's going from 1 to infinity? Yes. So you're going to say this is decreasing. The order you state it obviously doesn't matter. Continuous and positive. I am probably going to be writing D, C, and P because I get sick of writing it. You can't do that on the AP test or on my test. You have to actually write the words. Whew, what do you think of this test? It sucks, right? We're going to try not to use it. Sophie, are you ready? So the first thing you're going to do is, by the way, this would never lend itself towards this later. But today we're going to tell you to use the integral test. You're going to replace n with a what, Sophie? Yep. What am I going to replace that with? No. X. That's why I'm picking on you. You're sleepy. Pick on my sleepy people. All right, there you go. I'm going to replace that with an x, and now I'm going to look at the function. I'm going to verify that it's 3 things. What are they, Kev? It has to be decreasing. Are you convinced that as x gets bigger, that gets smaller? Yeah, don't take a derivative. If you were taking it, maybe some college professor who has a stick up his butt would make you do that. Just convince yourself, and I'm good. All right? Next up, what else does it have to be? Continuous, no holes, no asymptotes, no jumps. Are you convinced that that's safe for all real numbers? Yes. What else does it have to be?
Does it have to be all real numbers, or does it just have to be greater than?
All those greater than or equal to the start of the count. And actually it only has to be decreasing eventually. Like it can go up and down, but at some point it has to be constantly what they call monotonic. Like no, what it's saying is it could go like this, but eventually it's always decreasing. But you don't even it's not that big of a deal. You just have to remember to do it. So Kev says it is decreasing, it is continuous, and are you convinced it's positive? I am. So you're going to write F is decreasing, continuous, and positive, but you will write the words. We just don't want to. Okay? So therefore, I can launch into the integral test. What does the integral test say I do, Luke? It says I need to antiderivate and make an improper integral from the count up to infinity of a function. And I will see if this function converges. If so, so does the integral. I mean the series. All right, Anna? Do you recognize that integrand? Because I need to find the antiderivative. This is arctan. Okay? How comfortable are you passing to the limit? Because actually on the last test you weren't doing it. I'm going to pass the limit one more time because FRQ you gotta. Multiple choice though. The next one maybe I'll just treat infinity like a number. I'd have to take the limit as b goes to infinity, integral 1 to b of this function. If you want to get full credit, you gotta. It's a sucky test. All right, Anna said this is arctan. Is she correct? Yes. So even if it was 5 on the top, it'd be 5 arctan. If this was 9x squared, then it's 1 over a arctan. It's totally arctan-y. So we do limit as b approaches infinity, arctan x, right, from 1 to b. I can't drop my limit yet. You don't drop. That's why actually a lot of you lost a point on the last thing because you dropped your limit right away. You can't drop it until you actually answer the question. This would be arctan b. It's not time to go.
No, it's not.
Kevin, shut it. Yesterday, though, it was that early. I didn't think 4th hours ever got cut short. It was short yesterday. Wasn't it? All right, Preston. Here I am, right? I'm doing the limit of all this. And now let's answer the question. What is the arctan b as b goes to infinity? I'm saying no. I'm saying the tangent of what goes to infinity? Pi halves. Yes, this is pi halves. I'm saying the tangent of what is 1? Pi fourths. This has actually got an answer. This integral, by the way, if you were to math 9 this and put in 99, you'll get something really close to pi halves minus pi fourths. What's pi halves minus pi fourths? Pi fourths. So the integral converges. What does the series do? But not to that. We don't know what it converges to. We're going to find a window, and that's what I'm going to talk about next. All right, so let's answer the question. So we're going to say, therefore, the integral and the series, actually you could probably just write the series because that's what the question was about. So if you wanted to start your sentence right there. This series does what? Converges by the integral test. All right, now we'll answer the second part of the question, and this is where some kids choke. It might be the difference between an A and an A minus, to be honest, because this is something a lot of people don't get. So I'm going to try to do it slow. It's the best I can do. So go back up here. We're now going to try to absorb what this is saying. So I think what I'm going to do is take it out of its gobbledygook, and you're just going to watch. All right, and then we'll go back to this. Here's the deal. You're going to be told to approximate where that sum, I don't know what it is, I don't know what it adds up to, but I'm going to get what we call a safe window. I'm going to tell you this is the exact sum. All right? And I'm going to tell you I'm going to go out to the nth term. Like if that's 7, I'll do s sub 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, and then I'm going to quit. What did they tell you to use in this problem? S sub 4. They'll tell you. They'll say you're going to go out to 4, you're going to stop, and then you're going to use that to help you estimate. So under here, I want you to write S equals S sub 4 plus. It'll be the first 4 plus the rest of it. Agreed? The rest of it is called the remainder after that many terms. So the rest of this, you're going to do like this one plus this one plus this one plus this one. You're going to stop. You're going to figure out what all this is. All the rest of it is called the what? Remainder after the first 4 terms. If you knew that exactly, you'd know the sum exactly. So you're not going to be able to figure out the remainder. So what we do is we find what we call an upper bound. It's called an error bound. And that's going to be a theme throughout 2 other sections, so it will help if you get what you got going on here. This is the first 4. This is the remainder after the first 4. What we're going to do is find something bigger than that. Does that make sense? Then I'm safe that my sum is in there. I'm going to let you digest that. Agreed? So let's go back up here. It says that that remainder is always less than or equal to the integral from n up to the infinity. So what I'm telling you is I have no clue what this is, but it's always less than or equal to the integral of 4 up to infinity of the function. So what you do is you go evaluate that, and you get what's called a safe upper bound. So here we go. We're going to say that our r sub 4 will always be less than or equal to the integral. What do I put down here? 4. Some kids always put a 1 there and it throws it off. So it's whatever. If they stop, if it said to use s sub 6, then we'd say the remainder after 6 is 6 to infinity of our function dx. You have to go find this. But you also already did the antiderivative, correct? We already know what it is. I'm not going to pass to the limit. We're going to go like this. Arc tan of what? Infinity. Thank you. Minus arctan 4. You need a calculator. You guys go get me a calculator. Somebody with a calculator. You got one? Anybody? What is arctan infinity? So you're going to do pi halves minus arctan 4 on your calculator. We'll round it to, let's go fairly far out there. Since we're doing error, we like to keep it, I like it more than 3 decimal places. Can I get a backer on a 0.24497-ish? Thank you. All right. So this right here, my rest of my sum is always less than or equal to 0.244978. Sometimes I like to store that in A if I know I'm going to use it a lot, but we'll just keep it. Thank you. Let's go back up here. So this is how you tell me where it actually resides. My actual sum is in. I'm trying not to even look at all the theorem parts. I want you to understand it. What do you think the lowest it could possibly be is? S sub 4. It can't be lower than that. It's an increasing function, right? So it's always, sorry, decreasing function, but they're always positive. So right here is S sub 4. We'll go get a number for that, correct? What can it never go over? S sub 4 plus the upper bound on my remainder, correct? So it would be that. I'm going to go point at it. Now let's go get some numbers and test it out. Can somebody do, our S sub 4 was pi halves minus pi fourths. Can somebody do pi fourths as a decimal for me? It's going to be thank you, 0.785. This would be 0.785 plus that number. So Sydney, if you could go, this is the lowest it could possibly be, because I'm always adding positives to it. What'd you say? 030. Like that? I'm 100% sure that the sum of the entire thing is between those two numbers. And that's actually a pretty tight window. How could I make it way tighter? Yeah, I could have done S sub 99 and I'd be really close, right? So let's go try the original and see if it actually holds to be true. So you guys go take out your calculators. This is good. I mean, I'm not giving you a lot of homework, so you guys just got to hang in there. You're being good about it. But I told you series is a beast. It is. I want you to do this guy. Let's go to 99. So math 0. If you like to see the n, put your calculator in sequence mode, and then when you hit the, I don't mind the x, but if you're like, it looks better with the n, go put that on there. You will get a number between these two, or we did it wrong, because I'm 100% confident in that interval. The lowest it can be has to be the first 4 terms, right? And then I overshot, so if you math 0 that, maybe your calculator will let you go higher than 99, but what'd you get? Go ahead, Afnan. 1.06?
That's what I got too.
What did we do wrong? Did we add them wrong? I'm not seeing anything wrong. Is your pi halves minus arctan 4 wrong? Were you in the right mode, radian mode? Because that's right. Is your S sub 4 right? How'd you get S sub 4? Did you math 0 it from 1 to 4? I'm thinking S sub 4 is wrong. I don't know. Go check this. Go math 0. I don't think our math's wrong, so I think somebody gave me a bad number. Go math 0 that from 1 up to 4. What does it give you? That's it. Our lower bound was wrong. Point what? I sort of apologize, but whoever gave me this number, I'm going to blame. All right, we need to math 0 from 1 to 4. So that's going to shift. Do we need to shift the window? It is. Please, God, no. All right, so having said that, here we go. This right here is off the U of M test. I told you I got this series test from one of my former students. You're going to see that this has no choice. Here's the deal. You would try every other test possible, and all of them would fail. Nth term test for divergence is my first one, but what does that limit go to? What's the limit of that? 0, inconclusive. It's not geometric. It's not a p-series. It's going to fail all the other ones too, and you're going to go crap. Who did I say is the trigger for I have to do the integral test? Natural log. By the way, my gut, I don't know, and I haven't done this one from last year. A lot of times I go with my gut. But 1 over n alone diverges. Tell me why. It's a p-series with p equal to 1. It's the divergent harmonic, the most famous divergent series there is for a number of reasons that I won't tell you yet. But I know that diverges, and I'm contributing very little to the bottom because the ln graph goes like this, and I've got the 5th root of it. So I'm contributing a super slow growth to it. So I truly do not know what this one does. All right, so I have to take it from the grassroots. I go, oh crap, this is the integral test. I replace n with what, Sophie? Thank you. X, ln, x to the 1/5. I then verify in my head and on paper, let's see how good your memory is, that my function is 3 things. Chuckles, it must be. Do you think it is as x gets bigger? Yes. What else must it be? And what else must it be? Positive. You're going to state that. Is it almost time to go? Good. Oh, I saw somebody packing up. Don't bail on me. All right. So we're going to say f is decreasing. Hey, who haven't I picked on yet today? I did, Anna. Hey, Mitch, what if you don't write f as decreasing, continuous, and positive? What do you think? What if you don't write this sentence? Yes, sort of. You lose points is the answer to the question. On my test, I take a point off. You saw on the AP FRQ for this one, you didn't get either because it said it was 2 for it. So f is decreasing, continuous, and positive. There. I've met the criteria. So then what do I do? Let's see if you have the test down. Abby, do you remember what I do once I verify that we're dogs curse in prison? I will. Yep. So she's going to make it an improper integral. So let's go write that down anyway. This is what I need to consider, right? You might even want to write the word consider in front of it if you want to sound fancy pants. Yep. Yes, let's do that. Limit as b approaches infinity. The people listening can't hear you, so I'll repeat it. She said you replace the infinity with a b and you approach it as a limit. Awesome. Then what do you do? This is u sub. Yes, you might want to, this is where you have to be careful depending on the pickiness of your professor and the AP scoring rubric. So you got to be a little careful. Watch. I do it off to the side because it's probably not a u sub in my head one. Who you? Natural log of x. If you're never going to go back to that, you better change your limits. Do you want to go back or do you want to change limits? I don't care. You want to go back? Okay, that's fine then. So if you go back, remember you can't write these on your integral for u. So either leave them off or don't put equals so you don't have a linkage issue. But if you All right, so we've got du is 1 over x. I'm actually sitting here with the limit as b approaches infinity, right, of what? Sorry. Yes. Of the integral of u to the negative 1/5 du. Why did I leave my limits off, just so you can see it? My limits are for x, correct? So I'm leaving them off. Otherwise, you've got like a mixed variable issue. If you want to change them, go ahead. What is the antiderivative of that? Oh, yeah, sorry. I said it and didn't write it. All right, what's its antiderivative? I picked on Erica. I haven't picked on you. What is it? There. Good. Awesome. All right. Evaluated from where to where? 2 to b, right? Limit still. Yuck. Do we like this test? Not my favorite. Will I make you do it? Yes, you'll have to do it at least once, but then you're going to avoid it. For anywhere you have an option, you're going to try everything else. But this one, they would all fail, though. You'll be like, ah, she did it to us. All right, so let's go take a look at what we have now. We have limit as b approaches infinity of 5/4. This was on the U of M test. So if you're thinking like, why are you making them so hard? If you went there, this was on your exam. So would you have been able to do it, Sydney? Maybe. ln b to the 4/5. And depending on how picky your professor is would depend on whether even this was allowed. I kind of did a little, not quite sure that would fly if you had a picky guy, right? What goes here? I'm going to put the 5/4 in it, actually. ln 2. Now we can answer the question. Are you ready? What does the first part of it go to? Infinity. This is a constant. Agreed? So what's my answer? Infinity. So what does the integral do? Diverges. So what does a series do? Diverges by the integral test. Yes. I do. It's still a constant. I'm getting sloppy is why. All right, I'm going to quit because I feel you. I can't until I have you at least try an error because I goofed up on the one error one. All right, so nothing's due tomorrow. I'm going to give you the worksheet. It's going to be due Tuesday. But tomorrow we're going to take a break from series because they're heavy. Isn't it heavy? Yeah, so we're going to you need a break. And actually I like a break to let you forget everything. And then it comes back. All right, so this says to approximate the sum. So I don't need to verify that that converges. It does. By the way, it's a p-series. I'd never use the integral test for this. Wouldn't you agree? This is a convergent p-series with p equal to 4 greater than 1. I'm done. So this is not an integral test if I had my druthers. But this does tell me that I need to estimate the error. And we're going to actually approximate the sum. We're going to figure out where it is. So the first thing we're going to do is figure out what S sub 4 is. How do I do that? No. It could be 5, 6, 7, or 8. I just happen to have 2 in there. So you're going to go S sub 4. Does it say? Oh, sorry. God dang. I need to quit today. All right, so 6 terms. That gets done on your calculator to a, let's go 4 decimal places. Afnan's already typing for us, so you guys can chill for a second. But you use math 0 to do that. So whoever, I don't even remember, so I'm not mad. Whoever gave me the 0.7 whatever, we math 0, and I'm going to steal it. All right. He math zeroed and got a. Are you confident that this, you're in polar mode? Doesn't matter, but why am I looking at thetas? You guys are still in polar from the last time we used it. It doesn't matter, but it's weird. All right. That's the sum of the first 6. I want to figure out the remainder after those. If I could get that, I'd know the exact sum. I just do this plus what's left over. I can't, I get an upper bound. Do we remember how to get the upper? I just want to make sure you got this down because this was one of the most missed things last year on their test. I integrate from 6 to infinity. What did I tell you some kids do incorrectly? They go from 1. They don't get it. I'm trying to get, if I can, my remainder will be less than the integral. And I think that's kind of like because the integral adds up everything, and the series just does it at the, you see what I mean? So I think that's where, that's me saying something I'm not 100% sure of, though. So it just makes sense to me. All right, what am I going to integrate? 1 over x to the 4th dx. I need to go do that. So I need to go over here and integrate this sucker. Its antiderivative would be x to the negative 3, right, over negative 3. That's not a hard one. So it'd be negative 1 over 3x cubed. I am not going to pass to the limit right now because I'm burned out. Are you guys? So Kevin, wake up. This is its antiderivative. What am I going to evaluate it from? 6 up to infinity. I am going to use infinity as a number. So I'm not passing to the limit. I'm going to do it as if it's, this is actually would make a college professor who has a doctorate in mathematics and has OCD and make them roll over in their grave. That. But I don't care. Get over it, crabby old professor. All right. What am I subtracting? A negative 1 over 3 times 6 cubed. What is this going to go to? Gone. So on my calculator, you are going to do for me, Afnan, 1 divided by 3 times x 6 cubed. And we're going to go r sub 6 then less than or equal to. It's kind of impressive. You people are the only people in this entire building, probably in this entire district, because the other 2 schools don't offer VC, who have a clue what's going on here. This is hard stuff. What is it? 0.0015432099. Write it down. Now, that right there is an upper bound for the maximum error. Some books would call it the maximum error. We're going to tell you where S is. I don't know what it is. I know it converges. I know it has to be in a certain closed set. You guys tell me what that set is. I'm 100% confident, unless Afnan 2 gave me bad numbers. Were you the one last time? What's down here? Yes, the sum of the first 6. I can't go below that. It's positive, and I'm adding all the time. 1.00, what was it? Okay, what do I do to get my upper? Yeah, I add that on. I'm overshooting what the sum would be. Did you add that up too for me? Awesome, thank you. 1.08266. That's a tight window. Why is it so much tighter than the other one? There's actually 2 reasons. It's decreasing faster. 1 over n to the 4th is way faster than the last one we did. It was, I think, 1 over n squared, right? And I went out farther. So now let's try it. Hopefully Afnan didn't give me crappy numbers. Now let's go to 999. And I'm confident that it's in that window. Is it in there? Okay. And again, you could go to maybe try this. I don't know how until your calculator wigs out. But no matter what I put in there, it will fall in here. I'm done. Whew.